Okay, question number 5. A small toy boat is floating on the water surface. It is gently pushed down and then released. So the toy executes a simple harmonic motion. Its displacement time graph is shown here. So here you can see the displacement time graph. Okay, this is the displacement time graph. Now, for this oscillating toy boat, calculate its angular frequency, its maximum accelerations, its displacement after a time of 6.7 seconds, assuming that the effect of the damping on the boat is negligible. Okay, so A, I need to find the angular velocity frequency. So the first thing we need to know is what is the period. So the period from the displacement time graph is actually 2.0 seconds. So immediately we can know our angular velocity as 2 pi over t. So it should be only pi radian second, okay, over second. So you can make it as 3.14 if you don't want to remain it as a pi. Okay, so now part B. The question say what is the maximum accelerations? Okay, so again, a equal to negative omega square x, and you want to find a max, and then your angular velocity is constant all the time. So what you get is the x max. Okay, so so what is our x max again? X max is actually our amplitude. So negative omega square, I will place pi inside square. Now the x max here, which is given in the displacement time graph, is actually 3 times 10 power negative 2. Okay, which is our amplitude again, which is our amplitude. So finally you will get your accelerations as 0.296 meter over second square. So this is the maximum of the accelerations. Okay, now C, its displacement after time of 6.7 seconds, assuming that the effect of damping, so this is what is negligible, so this is we call it ideal case. So look at the displacement time graph carefully. Okay, the displacement time graph is actually a cost graph. Okay, you can see it's actually a cost graph. So I will use this relationship, ax equal to a cos 2 by f t. Okay, or you can do it as a, or you can say that it's actually also a cos omega t. Okay, now you get all the parameters already. You got omega. So immediately you can replace inside. Your a is 3 times 10 power negative 2. Okay, and then your cos, your omega is actually pi. Now times back the t. So the time that you require is 6.7. Okay, 6.7 seconds. Now pay very attention here. When you use the cos over here, okay, when you use the calculator, you must remember that to change it to radian. Okay, this must be in radian. Okay, it's not degree. Okay, it's not degree. Take away degree. Okay, whenever you do this oscillations calculation, this must be a degree. Okay, so finally after you put in everything in your calculator, you should able to get a negative 0.0176 meter.